Okay, today we're going to talk about rotations, which is the third type of isometry after reflections and translations. And you can see here the rotation is a rigid transformation in which the object moves around a fixed point, which we call the center. And it is an isometry. Again, it is a rigid transformation. You can see from this picture that the image has the same size and shape as the original figure. Okay, let's look at a different picture to point out a couple of key aspects to a rotation. The first is that the distance from any point in its image has to be preserved. So like if I were to measure the distance between point A and the center, it has to be the same distance as A prime in the center. And that would be the same for B in the center and B prime and any other point on this triangle. You also notice that if I connect a point and its image both to the center, that it forms an angle, and it's always the same angle. So the angle between A and A prime in the center is congruent to that of B and the center and B prime, and it would be the same if I connected C and C prime here. Right? This congruent angle is always going to be the same, and that is called the angle of rotation, right? That's what defines the rotation itself. So if you have an angle and a center, then you can rotate any object. And obviously, when I do, since it's rotated around a circle, as you can see in this picture, the distance is the same. And obviously, we could keep doing this multiple times, as you see in this next picture. Here you go, and you can see even here, even though I rotate no matter how many times or by what degree, the image is always identical in shape and size. It's always congruent to the pre-image. And notice one other thing, that the orientation is preserved. We mentioned this before. If I go in a clockwise naming the vertices, it goes A, B, and C, and back again. And notice for all of these images, the same pattern holds. A, B, then C. A, then B, then C. Remember, this is different than a reflection. And so oftentimes, if you're not sure what kind of transformation has taken place, this is a great way to test whether it's rotation or a reflection. If the orientation is the same, then we know it has to be a rotation. Let's look at some specific examples to see how we can actually construct a rotation. Okay, so here this first example wants us to rotate 90 degrees counterclockwise, and we do need to name a center. We'll call this the center here. So we want to rotate around this point. And so notice first of all that it's giving me a direction, counterclockwise. This is going to be given to us normally, but if not, it is actually accepted mathematically that counterclockwise is any positive rotation. So if for some reason it doesn't have a direction given to you, we can assume it's going to be going in that direction counterclockwise. But that's kind of getting ahead of ourselves. So let's see, the fact that this is a 90-degree rotation means that literally if I called this point A, I don't know why I put a prime there, if I call that point A, then if I were to draw a line to the center, I'm actually going to form a 90-degree angle, and obviously I'm just eyeballing it here, but if I draw a 90-degree angle, A prime must be somewhere on this line. And it's not just somewhere, it's at the exact point where distance is preserved. So if you can imagine traveling along a circle at this distance, A prime would have to be located exactly right there. And obviously we could try this with a protractor or something. Let's take a look at, just in case you've forgotten how to use a protractor, we want to line up this bottom line with the line connecting the point and the center, and then I would look around here for 90 degrees, and basically we would just make a point and then use a ruler to create that line that forms our 90-degree angle. And then of course I would use a ruler to find the correct distance, or in this case I've got it lined up so I know exactly this is where that A prime should be. Right? So I would line it up and I would do that for each of the points. But since this is difficult without being in person with the protractor and ruler, let's go back to this image. And so the idea is, once I've found that point A prime here, I would maybe kind of start over and pick my new point. So maybe this is B. I'm going to basically, again, draw a line, try to create a 90-degree angle, and preserve the exact same distance, and so B prime would be somewhere around here. And I would continue this. Let's try call this C. Again, I would draw a 90-degree angle, or excuse me, draw a line, use my protractor to find a 90-degree angle. So maybe somewhere over here I would rotate around to preserve the distance, and maybe this would be our C prime. And I know it's getting kind of cluttered, so let me clean up a little bit of some of these lines here. And so let's say, I'll go back to red here. D, same thing's going to happen. I'm going to preserve the distance, and D prime would be around here. Again, we would do all this with the ruler and a protractor to be exact. And so if I connect these points now, we have a pretty decent image here. Obviously this is very inexact, but you get the idea. The point is, I literally, if I were to draw a line connecting any point to the center and then to its image, it's going to form a 90-degree angle if I measured it with the protractor. But let's take a look on the coordinate plane and see if it can be a little easier. When I'm on the coordinate plane, I have the advantage of being able to calculate slope. And sticking to these 90 degrees right here, we know that means that if I'm going to connect a point to the center, notice it doesn't say what the center is. So let's put that on here. Let's say around the origin. That's going to be where we start, at least. The simplest way to rotate is around the origin. But the idea is if I were to connect any point to that origin, I need to draw a 90-degree angle, and I'm going clockwise, so I know it should land down here in quadrant 4. But it has to form a 90-degree angle. I'm creating a right angle with this, meaning I need to draw a perpendicular line. So this line that I've drawn here has a slope of up 3 over 1 of -3. So I need to have a slope of 1/3, meaning if I go down 1 and over 3, I know A prime must be located right there. And I can use this fact to my advantage, right? I can do this again for W, for instance. W here is horizontal, meaning W prime must be at a vertical line, so W prime would be right here. And point N, again, the slope is up 3 and over 5, a slope of -3/5. So if I have a slope of positive 5/3 going over 3 and down 5, N prime would be located right here. And if I connect all these points, here is my image. And you can kind of see, I hope that, again, if I were to draw a line, say, connecting A prime and A right here, you can see that that's a right angle. And I could keep doing that for all of my points. So, and here I have, again, the same orientation. So A, W, N, A prime, W prime, N prime. I have preserved my orientation, and I have created a congruent figure. So this is how we rotate. Let's look at one more example. And this time we're going to rotate by 180 degrees, meaning if I connect N to the origin, and then N prime must lie on a 180 degree line, meaning a straight line. So N prime must be located right here. Right, and then E, same thing. I'm just drawing straight lines. The slope should be the exact same now. So I'm going down 2 over 4. I should go down 2 over 4. There's E prime. I is going to be straight down 4 for I prime. And then L, of course, is over 3 and down 5. Keep that up, which is right here, L prime. And so again, we can see real quickly, here is my figure. And again, this is a good example. 180 degree rotations are a good example of sometimes being difficult to tell whether it is a reflection or a rotation. Right? It kind of looks like if I were to reflect over, say, the line y equals x or something, that it would look similar to this. But again, the orientation can come in handy here. So if I look at the rotation, we can see again that I goes to N, and N goes to E, and E goes to L, that the same thing's happening with our image. So it is indeed a rotation, not a reflection, if that was not clear.